Welcome to another episode of Simple Python. In this video, we will take a quick tour to the famous Pandas library and some useful functions to help us make some early assumptions for our data. First, let's see how we can manually create a data frame. To do that first, we import the Pandas library. Then we write the following code, passing into the data frame function a dictionary where all the keys are the column names and all the values are the actual values to be shown in the columns. To add a new column to an existing data frame, we can simply do it using the following code. On the right side, it can be any valid operation. Pandas data frames can easily handle dates. Let's add to our data frame a date index. Notice the format. We are passing into the date_range function the starting point, and we give the number of periods, in this case 5 as we have 5 rows, and finally the frequency indicating the interval to move up from our starting date. We pass d, now indicating days. In Pandas, we can easily retrieve useful information like the mean, max, and other statistical measures. The catch here is to be careful if you want to retrieve them by row or column. The default action is column. Let's investigate all the different ways. Slicing a data frame is also quite challenging as Pandas waits for a specific format when you want to retrieve specific rows or columns. In the brackets, we give the range of rows or columns we want to slice. Note that we start from 0. First, we give the range for rows, and if we want also column, we pass it after comma. Pandas also gives us the ability to apply some custom formatting to help us quick indicate different data points. For that, we have to write our custom function to do the task we want. In our example, we are going to mark the max values in each column. For more information on the style string, check the documentation on Pandas' official page. We can apply the same function to mark the max in each row, instead using the axis arguments. Now, let's work on a dataset with information on the famous iris flower. The dataset has different measurements on the petals and sepals width and length. First, we read the data. Using head and tail functions, we can see the top and last rows accordingly. Using the info and describe functions, we can see useful information of the underlying data, like if there are missing values, or some strange numbers like minus values for features like length where that is not possible. By using the drop method, we drop every column or row we want using the axis argument. The in-place argument reassures that the change we replace the original dataset. Group by gives us the ability to group data, sharing a common feature together, and ask for useful information, like the mean in our case. Now we can use our previously function to highlight the max values in each column, or even highlight the values that are smaller from the mean among all 3 species. So, that's all for that quick introductory video. I hope you found it useful. Thank you for watching. I will see you in the next one.